All right, folks, how's it going? It's Mr. Whale here. If y'all are watching this video, it's because you have a sub. All right, so what you're gonna do is complete this video, just watch this, and then after that, you can get on with the sub assignment. And then after that, if you finish the sub assignment, you'll have time for practice problems to work on those. All right, folks, real important you watch this video. It's got the best stuff in it. Okay, so we're doing lesson 14 and 15 today. Lesson 14 talks about alternate interior angles, which you might remember from our Unit 1 vocab day. Okay, so let me show you what an alternate interior angle is real quick. Okay, so alternate interior angles occur when we have two parallel lines. Okay, I'm going to make these lines as parallel as I can. Okay, when we have a line that intersects two parallel lines, we call this a transversal. All right. Now the alternate interior angles are the angles that are inside the parallel lines and on opposite sides of the transversal, as you can see here. Now something that's really cool about these lines is that, something that's really cool about these angles is that they are the same. Okay. They will always be the same and equivalent to each other. All right. So again, these two angles here I've drawn are alternate interior angles. Also, these two angles here are alternate interior angles. All right. These two, not. They're interior, but they're not on alternating sides of the transversal. These two are on opposite sides of the transversal, so they're alternating interior. All right. And like I said before, as you can see, these angles are the same. Okay, so I can't really move this, but let me show y'all what I'm talking about here. All right, so if I move this a little bit, okay, we can see that this angle, oh dear, I've done the wrong angle. That's all right. We'll talk about these alternate interior angles. Okay, so the cool thing about these being the same is you can prove it, right? Now, not yesterday, but on Monday, we talked about proving congruency, proving that things are the same using rigid transformations. If I was to rotate this angle around the midpoint of this line, right, 180 degrees, it would rotate and line up exactly with this other angle. So now I know these two angles are the same. All right, so alternate interior angles are equivalent. All right, now we can also use this same idea to understand that some of the other angles in this picture are the same, right? Oops, don't go away. For example, these two angles here, all right? So I've got one of my alternate interior angles. This is not an alternate interior angle, but I want to show y'all something. If I translate this angle up to the next angle, I can see that they are also the same. Now, because that's a rigid transformation, it proves that these two angles are the same. All right? That is the idea. This right here is how we get alternate interior angles, and that's how we prove that those alternate interior angles are the same. All right? So again, proving congruency works with angles. It also works with shapes. All right? So here, right, when we have these lines, okay, this was one of the activities. It was telling us was asking us to fill in kind of the missing angles. So go ahead and try doing that on your own. This activity is on page 131. You can pause the video and do that. Okay, if you're at this point, I'm assuming you've worked through it a little bit. All right, so on here, we've got a similar thing going on. Okay, we've got this angle here. Now, if I rotate that angle 180 degrees, I can see it's the same as the other one. These two angles here are called vertical angles. They are on top of each other, right? They are vertical from each other, or they are across from each other. Vertical angles are also the same. So I know that's 63 degrees. Now, these adjacent angles here, these two, they're what's called supplementary angles, which you might have heard that term in 7th grade. Supplementary means they add up to 180. So this angle here and this angle here, they add up and they equal 180. We know they equal 180 because they're on the same side of a straight angle or a straight line, meaning that these two angles added up are going to equal 180. So what's 180 minus 63? Oh my gosh, I'm not so sure. I think it's 117. Okay, there we go. So that's how we can figure that out. Well, 180 minus 63 does in fact equal 117. So we know one of those angles. That's great. Once you get that, it's really easy to finish the rest. We've got another angle that is vertical to that one, so it's 117. And then up here, this is where it gets interesting. Whoops. So I can take this angle, I'll call it angle B, because there's a B right there. And if I translate it up, I get angle E. So because that was a rigid transformation, angle E has to be 117 degrees. All right. Also, if we look at angle B, this is where it gets crazy. It all starts to make sense, right? The alternate interior angle to angle B is this angle here. They are on opposite sides of the transversal. They're inside the parallel lines. So this also has to be 117 degrees. Okay? I can also use alternate interior angles to figure out what this angle is. This is alternate interior angle to this angle here. So that's 63 degrees. And then this other one up here also has to be 63 degrees because it's vertical with the other 63 degree angle. All right? So that's how we can fill that out. Okay? If you have any more questions, the lesson summary on this lesson is super helpful. In fact, what I would do is I would mark page 136. All right? Big page, very good. Lots of impressive things happening here. They talk about vertical angles, right? They talk about adjacent angles being supplementary, vertical angles being equal. They also talk about the transversal and alternate interior angles and how those are created. Okay, very, very helpful. Also, if you look at this diagram here, the angles, they're all either 70 degrees or 110 degrees. Let's look here on this line, right? What's 110 plus 70 degrees? Well, it'd be 180, right? Because they create a straight angle. Perfect. All right, so that's lesson 14. Really just talking about transversals, okay? If we move on to lesson 15 talks a little bit more about straight angles. So I want to show you all the lesson summary here, okay? Let's actually move this so we can actually see the full thing, all right? So we see here a straight angle. It's pretty fantastic. Kind of looks like a little dude with a nose peeking over that line. Anyway, maybe he's got some hair too. Maybe he's got some wild ears that are coming up. Anyway, I'm getting distracted. I'll get back to the point so we can continue on with this lesson. You can get on with your assignments. All right, so a straight angle is 180 degrees. Very cool. Now, we also know that all the angles in a triangle add up to 180 degrees. It says here that the sum of the measurements of three angles in a triangle is 180 degrees. There's something really cool with this, all right, that we see here. If we take any triangle and we separate those angles and we put them all together, we'll see that, in fact, those angles create a straight line, or 180 degrees. Let me show you all this with just a random few lines. Let's see how this works. So I'll create an angle here. Maybe I'll make it that big. All right, I'll create another angle. Let's do this one here. Here. And then I'll do a final angle. That will have to be the straight angle. We'll put that one here. Okay. Now if I take these angles and I separate them, right? I know already that those lines all together make a straight angle, right? Kind of looks like the thing right here, right? Right there. Okay, so I can also make a triangle out of them. Watch this. Ooh, getting crazy here. I might have to shrink this one a bit, but Ooh, I'll just make this angle bigger. There we are. You see, it creates a perfect triangle. All right, now that'll work with any set of lines, any three angles that add up to 180 degrees or make a straight line. Really crazy stuff. Let's deconstruct it again. See how that makes a straight line? It also makes a triangle. This stuff's crazy. All right, so that's really all lesson 15 is about. Okay, just kind of helping you realize that any three angles on a triangle will always add up to 180 degrees. Okay, they will always make a straight angle. That equals 180. Okay, so if you know two angles in a triangle, well, let's say like this one's 90 and this one's 60. Okay, 180 minus 90 minus 60 equals 30. So that last angle has to be 30 degrees. Okay. That's how we can solve these problems. All right, y'all go ahead. If you've watched the rest of this video, go ahead and where your Chromebook's open already, I'm assuming, because you've accessed this. You can access the sub-assignment from the weekly check. That's my home page on my Canvas assignment. Just go there, scroll down. It'll be next to Wednesday or on Wednesday, all right, underneath where you found this video. All right, give that a go, folks. Good luck and enjoy the rest of your day. I'll see you Thursday, all right? Bye.